Hello everyone. For today's tutorial video, I'd like to explain how density affects the physical motion of an object, both in cases where it is moving in straight lines and where it is rotating. Unlike something like mass, which depends on the shape or volume of an object, density is an intrinsic property of a material. And this is always true, regardless of whether we are studying solids, liquids, or gases. The mathematical formula for density is rho, spelled RHO, equals mass divided by volume. So this formula states that density is a concentration of mass per slice of volume, and generally depends on the chemistry of the material. For example, silver is much less dense than gold, for the simple fact that they are different elements entirely. Since we know, from the formal definition of density equals mass concentrated over a slice of volume, we can accurately predict that two objects made up of the same exact volume, but one whose material has a greater density, will have a greater mass and therefore weight. For example, going back to the Pop-Tarts demonstration, we can see they have approximately the same geometric volume, but this one will feel heavier, aka more massive, because it has more Pop-Tarts in it than this one. As you may have already noticed yourself, almost all real-world objects are much more complicated in terms of what materials they are made out of than simply just one material throughout the whole thing. For example, if you have ever used a claw hammer, you will most likely already know that the wood and metal at the head have entirely different densities, and this is important to recognize to figure out something like the center of mass of an object, as the center of mass will want to be concentrated at the place where the object is the most heaviest. So if an object has a uniform density, aka the same density material throughout the object, the center of mass will want to be concentrated at the geometric center. But if an object is instead a more complex sum of different material densities, the more dense materials will cause the center of mass to go toward the place where the density is greatest. So in the hammer example, the center of mass would be more close to the head, as the metal is much more dense than the wood, as the wood is made up of mostly carbon. The center of mass may seem like useless trivia at first, but will actually be a vital tool in describing the motion of an object as accurately as possible. As for example, an object will want to rotate with reference to the center of mass, if there are no fixed points, like a hinge, for it to rotate on already. In the next tutorial video, I will touch on linear momentum and a revised, more accurate version of Newton's second law stated in terms of momentum rather than simply mass. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.